Alright, welcome back to another round of Unit 2B review. We're on Activity 11, and it is all on arithmetic sequences, which was one of the easiest lessons in the entire first semester. So I'm really excited about this one. So basically, an arithmetic sequence, a sequence is just a list of numbers. So all of these in your guided practice right here, all four of these are an example of a sequence. That sequence becomes an arithmetic sequence if the difference between two consecutive terms is constant. And that difference is called your common difference. And that's, so basically if I take two terms that are side by side and subtract them, I should get the same thing as if I took two different terms side by side and subtracted them. So the difference, I should be adding or subtracting to get to the next term. And I should be adding or subtracting by the same number. Okay, and then over to the side, we have two formulas. We have the recursive formula, and we have the explicit formula. The recursive formula basically uses a previous term and adds the common difference over and over again. The explicit formula, you're able to plug in which term you want and do some math magic and get the term you wanted out. I'll be very frank with you. I prefer the explicit formula 100% of the time. I don't really care for the recursive formula because you need the previous term before you can do that. So you would have to, if you don't have any of the previous terms, you would have to use the recursive formula over and over and over and over and over again. I mean, you can do it. And if I only have to find a quick term, like if I only have to find like the fourth or fifth term, I typically do this instead of writing all this out. But if you want the 100th term and you don't have the 99th term, you're going to have to do this 99 times before you can find the 100th term. Whereas with the explicit formula, you could plug in 100 for n and get your term out. So again, I prefer the explicit formula. Recursive has its uses, but not very often. So okay, so let's go ahead and jump into the practice. Alright, so given each sequence, determine if it is arithmetic. And if it is arithmetic, state the common difference. So again, we're just seeing, does it have a common difference and what is it? So number one, to get from 2 to 4, I add 2. To get from 4 to 6, I add 2. From 6 to 8, I add 2. So because it has a common difference of 2, it is arithmetic. So yes, it's arithmetic, and the common difference, which we're going to use D for, is 2. Alright, number 2. To get from 1 to 2, I add 1. To get from 2 to 4, I add 2. I could continue, but I already see that this is not constant. So no, this is not arithmetic. There's no common difference. Okay, number 3, to get from 18 to 15, I subtract 3. From 15 to 12, you subtract 3. From 12 to 9, you subtract 3. It has a common difference, so yes, and my common difference is -3. Okay, to get from -1 to -8, you subtract 7. From -8 to -15, you subtract 7. So there's only 2 places for me to subtract, so there's not a lot of data, but from what I have, it is arithmetic. And my common difference is -7. Alright, so 5, 6, and 7, we are writing both the explicit and the recursive formula, and then finding the 25th term, or a sub 25. Okay, so let's start with the recursive formula. The recursive formula has 2 parts to it. We have to identify the first term, which is a sub 1, and in this case it's 8. And then to get my nth term, we take a sub n minus 1, and we add our common difference to it. So let's just find our common difference real quick. I'm adding 6 each time. So we take whatever, so if we're looking for the 10th term, we take the 9th term and add 6. That's it. So that's the recursive formula. Again, remember, it's not very useful because if you need the 10th term, or if you are trying to find the 10th term, you need the 9th term. Well, if you don't have the 9th term, you got to use the 8th term. And if you don't have the 8th term, you got to find the 7th term, and so on and so forth. So that's why we give you the first term, so you can start with 8 and just add 6 until you're there. Or we use our explicit formula. So our explicit formula, what we do is we take our first term, which is 8, plus our common difference, and we're going to take that common difference and multiply it by n minus 1. So remember, this is our first term. So we don't want to plug in 1 and accidentally add 6 and get 14, because that would be our second term, not our first term. So that's where the minus 1 comes in. So if I plug in 1 minus 1 is 0. 0 times 6 is 0. Plus 8 is 8. So when I plug in 1, I get 8, which is my first term, which is what I want. I want to be able to plug in my term and get... or plug in my term number and get my term out. Okay, then it asks to find the 25th term. So we're going to take 25 and plug it in for n. Okay, 25 minus 1 is 24, so we're going to do 8 plus 6 times 24. And we'll do that with my calculator. So 24 times 6. Add 8 to it. Get our 25th term is 152. Alright, so we're going to do the same thing with 6. So we'll do the recursive formula first because I like it the least and I'd like to get it out of the way. So we list our first term, which is negative 5. And to get the nth term, we take the nth minus 1 term and add our common difference to it. So let's look, what is our common difference? So to get from negative 5 to negative 10, we subtract 5, and we keep subtracting 5. So we'll put minus 5. You can do plus negative 5, but the fewer signs you have, the less chance you have to screw up. So there we go. Okay, our explicit formula is a sub n equals our first term, which is negative 5, plus our common difference, which is negative 5, so we'll just do minus 5, times n minus 1. Okay, we want the 25th term. We'll plug 5 in for n. I'm sorry, we'll plug 25 in for n. I was writing a 5 at the time. Okay, negative 5 minus 5 times 24. So 5 times 24 is 120. So we have negative 5 minus 120, which will be negative 125.
And now you reward yourself with cake.
Yay! My husband brought me cake, and it's hot. Okay, so let's move on to number 7. Okay. Man, I'm getting distracted by that cake. It smells good. Okay, number 7. So this one's a little different because it's a graph. It doesn't look like a sequence. So our x-axis are the term numbers. Let's see if I can spell that today. And my y-axis is the actual term. So this is telling me that my first term is 2. My second term is 5. My third term is 8. So there we go. I've got my sequence. Okay, so let's go ahead and do our recursive formula. We'll do it up here. So a sub 1 equals, my first term is 2. And a sub n equals a sub n minus 1 plus, so this is increasing by, we went from 2 to 5, so it's increasing by 3. Okay, so there's my recursive formula. My explicit formula, first term again is 2 plus 3, which is my common difference, times n minus 1. I want the 25th term. I'm running out of room, so I'm going to skip a step. We're going to go ahead and do 25 minus 1 is 24. 3 times 24, 72, and 72 plus 2 is 74. Okay. So something to kind of point out, arithmetic sequences are a very special version of a linear function. It has a constant difference or a common difference. That's also like a constant rate of change, which is kind of like a slope. That's all the same thing. The difference between an arithmetic sequence, well, I don't want to say the difference between an arithmetic sequence and a linear function. Most linear functions are connected. It's continuous data. Arithmetic sequences are discrete because you have terms. You have term number 1, term number 2, term number 3. You can't have a term number 1.5. The term between 1 and 2, there isn't one. That would just become, that 1.5 would become your second term, and that term 2 would become your term 3. Term numbers are always whole numbers. So an arithmetic sequence is pretty much just a discrete linear function. Also, there's no negative domain either. Your domain for an arithmetic sequence is whole numbers starting with 1. So, and then it goes on forever, but it's whole numbers, but you start with 1 instead of 0. So I guess you could just say it's the set of natural numbers. So yeah, so there's that. Okay, so let's move on to this. This was, I don't know if you remember, this is directly from a lesson in the Springboard text. If you're in my class, we had a packet with this question. And it asks you to, since this can be considered a linear function, we can use function notation. We can do f of x instead of a sub n. It's the same thing. You could also do f of n, since we're talking about terms and term numbers. So we'll use f of n. So we could fill in this sequence. Right now we're adding 3. It's an arithmetic sequence, so plus 3 plus 3. So my next term would be 16. Then 19, and then 19 plus 3 is 22. So I can either use the terminology a sub 4, or I could do f of 4. It's the same thing. So it's asking, what's the formula for this sequence? Well, let's use explicit formula. We take our first term, add our common difference, and put n minus 1. So when it asks what function, we're basically just changing this a sub n to an f of n. Okay, so 7 plus 3 times n minus 1. And we could also simplify this. We could distribute my 3, combine like terms, and 7 minus 3 is 4. So we could also have f of n equals 3n plus 4. And now it's in slope-intercept form. It has that slope, and it has that y-intercept. So number 10, what is the common difference, and how does it relate to the function you wrote in number 8? Actually, I think that should be number 9. We wrote our function in 9. So the common difference is 3, but it's also the slope of the function. Alright, so your common difference and the slope are the same thing. So again, this whole section, it's nothing different. It's just saying, hey, instead of using a sub n, let's write it as a function. Boom, it's the same thing. We're good. Okay, so actually the second page is independent practice. So this one was really short. So congratulations, I made a video in under 15 minutes. Go me. So you guys have a great evening. I will talk to y'all soon. I'll have another video posted shortly. Y'all have a good evening. Bye.